Welcome, everyone. I'm Niccolo Stefani. I'm the population health leader at DeepHealth. And today we are here to talk and to spend the next, 35 minutes in talking about how we can scale up AI and speed up, development of a new AI model. And with me today, I have the pleasure to have Dr. Khan Siddiqui, CEO of HOPPR. Dr. Jason Sinner is medical director of West Coast at RadNet, and Yorit Glastra, that is the head of technology, so R&D leader at DeepHealth. So for the one that maybe don't know yet, but last year, DeepHealth and HOPPR, they signed a partnership and they decided to work together really to improve and make sure that we can bring a new way of working, new workflow in the way we develop and scale, model, like foundational model and machine learning model. And that collaboration started 1 year ago. And so we did a lot of things together, including, of course, looking at how we deploy these in our center at RadNet. And Dr. Tsina is going to talk about this later. And so because now it's just like, more or less 1 year we're working together, I would just like, to give the floor to Khan, and you can tell us again how, the collaboration was going and what we are working together and what we see really as an outcome of this really fruitful partnership.
Awesome. Thank you, Niccolo. It's great to have Jared and Jason on the call too. I think that the HOPPR's vision really started with some of us radiology as we're seeing in clinical practice, how the point solutions coming out for indication by indication were really slowing things down and not really solving or bringing the promise of AI to the clinical practice. And we had this vision that the AI should be in control by the teams themselves, by the clinicians, by the practices themselves, and how they can fine tune models to their specific settings. One of the other limitations of point solutions is that they don't perform the same across sites. So especially when you have multi-hospital health system or multi-site imaging center capability, because of variation in devices, scanners, even practice patterns, right? Not all of us scan exactly the same way. Different techs do different things. Different radiologists prefer different type of settings on these images. You see different performance across the board. Plus, even the radiologists themselves are on a different ROC curve, right? Some junior radiologists overcall, senior radiologists undercall. So the AI needs to kind of be tuned according how their things are. So that was the vision, like how do we solve this problem? And we really thought, like, let's build a platform that gives that control back to the radiologists and their teams to be able to very quickly build and deploy models on the platform. That's how the vision started. You guys were one of the early partners with us, amongst many others. We work with you guys to see how we can make these tools much, much, much easier. So instead of taking 2 years, few $1 million to build an AI model, then you do it in a week. It was a very ambitious goal to do this, and hopefully we've achieved that. And we'll see how Jared talks about that and how what your experience has been in that aspect of it. But that's where we are. We kind of talked about this at RSNA last year, and since then we've been working with our lead customers to enable them to deploy their own models much, much, much faster in clinical practice. So yeah, that's how we started, and the partnership is going really well. And back to you, Nico.
Yeah, thank you, Khan. And I think it's super exciting. And I think if we move really from again the theory to the practice, no. So now we have Yorit with us. So Yorit, as I said, is leading our R&D team at DeepHealth, and of course our ML team. So Yorit, if you look now at the collaboration and of course the operation, like fine tuning of model, how you're experiencing the partnership, how actually you're using the platform. So what is really bringing this to you and to your team in the real practical experience?
Thanks, Nico. Yeah, as Khan pointed out, I guess historically the approach was always been to train a highly specialized model from scratch, take several years, maybe a couple $1 million to get that done. And the promise, I think, that foundation models that everyone is quite familiar now with from ChatGPT and other domains is that they have been pre-trained on so much data that you should expect that they generalize quickly and well to new tasks. So they have seen so much, and that's all down to better hardware, but also smarter approaches, right? How can we do self-supervision smart, and how can we do use supervised data in new ways? And I see the HOPPR team breaking ground there. And that results in vision language models that can then be fine-tuned, and we should expect that to work for new tasks with limited annotated data. And what's nice, I feel, about the HOPPR platform is that that process of building new applications, adding new applications based on a foundation model, has been made very accessible. The process that you use for this is called fine-tuning, and you call that fine-tuning because you don't train the model again from scratch, but you actually take a couple of parts of the model and adjust those just to do well on a new task. And the HOPPR platform gives the developer, so people in my team, but also others, the ability to get full control over the performance in a way that is so easy that indeed also at the clinician level, you should be able to get these jobs done. And we'll touch on that in a few minutes too. The nice thing too is then if you use your own data, which could be limited annotated data for a new task, it will also be tuned to your situation, right? With the operating environment that you are in. And that's the second link, I think, to Kaan's comments. It's not a generic model trained to do well all across, but it could be a model trained for your specific population, situation, environment. So those are the benefits to me. We take a very large pre-trained model and we rapidly fine-tune it for new tasks, and that also allows more rapid experimentation.
Yeah, I think this is really key. Now really you get from a generic model and you fine-tune for the use case and make sure that, of course, like is working really well and delivering the outcome for the selected use cases, and how that you can do faster enough so that we can deploy to our patients soon. So I think I heard that, of course, this process is pretty simple. And again, also for someone like me, I'm a physician that also I can understand it. So that means it's simple. And what you can do, maybe, Yorit, you can show to us a little bit, how that works, how simple it is. And I think, keep in mind, I think, as you said, that this can really also be done by, a hand customer as well, no? So it's easy enough, and you don't need, of course, any regulatory approval to, and a customer itself, he could do in his own practice. So that's important also to mention. So Yorit, maybe you want to show us a little bit how the flow, how the overall process work. And again, if you have any question in the meantime, we go to the flow, please feel free to type in the chat and we're going to answer at the end. Please, Yorit, go ahead.
Yeah, thanks, Nico. So as I explained, HOPPR has made this fine-tuning process highly accessible. The current exposure is through API-based access. And that means if we were to demo that, that would result in a lot of sort of very dark screens with me typing commands into it. And to give the right feel of the ease that they've provided now to doing this, rather than doing that at the command line level, I wanted to just show you through the steps of the process to show you how easy it is. I just need to get my share up. Let me know if that works. Yeah, we're good. Okay. So the first thing you need, of course, if you're going to fine-tune a model, is to get your fine-tuning data ready. And there's only two bits you need. You need a set of DICOM images. Those will be placed in an S3 bucket in AWS. It's an easy thing to do. And if you can't figure it out, then ChatGPT can tell you how. And the second thing you need is a set of labels for those images for the task you want to fine-tune on. And again, they're very basic format, very straightforward format that the HOPPR team has selected for that you can easily prepare. And through the API, you place that data set in their system too. So now you have a set of images and a set of labels. And the next thing you do is you trigger the training, the fine-tuning on those labels. Again, this is a single API call. There are a couple of parameters that you can set. The most important there is a base model. Of course, you're going to fine-tune a model, so you need to select a model to fine-tune from. And in our case, we've been experimenting with HOPPR's chest radiography model, but you could select others as they become available. Really, that's the only thing you need to pick. You do have more freedom if you want to do more advanced things. So you can do stuff like set a specific training hyperparameters. Again, if you know what you're doing, this may be beneficial, but if you just want to get started, that's optional. You don't have to do that. Then inside HOPPR's AI infrastructure, this fine-tuning job will take place. At this point, you can just sort of lean back and wait for it to finish. The only thing you need to do is check periodically whether it says finished yet. And that's the other reason to focus maybe more on this process than actually demo it. That can take a bit of time, and there's not much to see while you wait. But rest assured that in the meantime, the big machine is chugging along to figure out how to adapt the big foundation model to your specific task. When that process finishes, the API will let you know. It will say, okay, now this job is ready to be run in inference. And the first thing you can do there is actually evaluate it on some cases that you've been holding out to figure out how well the model is doing. And again, here you're in full control. So you can look at those evaluations yourself. You may find that from error analysis, that there are specific subtypes that you want to do additional training on. That would mean you can do this loop one more time. But really, from that evaluation point of view, your model is also ready for deployment. So once you're comfortable with the performance of the model, it's the same API that you would use for deployment. So there's no extra steps. There's no moving things around. After your model has finished fine-tuning, the evaluation and the inference are really just the same. You offer it an image, and you ask it to invert that specific fine-tuned model, and it will do it for you. It's as straightforward as that. Again, if you have a set of DICOM images and a set of annotated labels for the task you're trying to fine-tune on, these are the steps you need to go through. Really straightforward to execute. Thanks, Nico.
Great. Thank you so much. That's really clarify and see how it is make the task easy. And again, for us as an industry, that we try to bring model fast to our customer, but as well, I think is if the customer himself want to fine tune for their population. So if we look now, we go really to why we are doing this. Okay, I think of course it's important to accelerate the development of this model, and what is more important is that the outcome that this model really can deliver to the population, to the patient. And so we have Dr. Sinner with us today, and the work we have done together with HOPPR, at least one of the focus is really trying to solve the problem of X-ray, in this case, like chest X-ray, because of course, like high volume examination, et cetera. And I think what, better example is to have Dr. Sinner to give us a little bit the size of the problem. So why, for example, we decided with the HOPPR DeepHealth and now, of course, like a RadNet, why we decided to focus on the X-ray. So maybe Dr. Sinner, you can give us an idea of the size of the problem, at least for RadNet as well, but why X-ray could be challenged in the time today.
Sure, absolutely, and thank you all for having me here. Much appreciated, and love to kind of chat a little bit about this topic. It's near and dear to what I kind of deal with and work with on a daily basis. I think the starting point is that at RadNet, kind of system wide, we're doing upwards of 2.5 million X-rays per year. I think that's a pretty staggering number, and I think any of us in this industry understand that there is a shortage of radiologists and physician extenders to the point that it's very challenging to provide high quality, timely service. And so we need to think of ways to be able to do that in a more efficient manner. X-ray in particular still has and always will have tremendous value to our referring physician base, and it still answers a lot of important questions and or acts as a gatekeeper to facilitating other examinations, and you have to be able to answer those questions appropriately and do it in a timely way. And so, in order to do that, you need to create both efficiency and clinical quality. And I think that's where this accelerated AI model comes into play is that, if we can assist the radiologist with, in multiple facets in terms of creating that efficiency, whether it be, sorting examinations to allow us to bring certain ones to the top of a list that need, immediate attention. Because in the real world, yes, we'd love to be able to turn exams around, in 24 hours or even shorter than that. But in the real world, there are exams that we need to get flagged so we can pay attention to them immediately. So that's one way to do it. And another thing that's, I think, super important is the kind of the concept that we want to provide a high level of detail on each one of these examinations, and to be able to have a model that will allow us to sort of pre-populate, if you will, into our reports or into our thought process, at least some of that detail that otherwise might not get included. If that information, that additional information, can be efficiently included into our reports, that just provides additional clinical value, and is obviously kind of trickles down to better patient care.
Thank you, Dr. Sinner. And I think if we zoom in a little bit, I think in our practice, what we are testing out is really like the kind of like the really like segmentation, I would say, triage between what we define remarkable, unremarkable. So when we say remarkable and unremarkable, we mean like an absence of finding, like of like 6-7 select finding, but also the segmentation of normal. So if we zoom in a little bit on, okay, now we try to really like put the examination, the X-ray buckets, in these three category. How these you feel now can help clinically and of course operationally. So what can derive from this kind of workflow as an advantage operationally and clinically for you and of course your team?
Sure. So if there are certain components that can be flagged immediately, it allows us to sort our work lists appropriately. If you have tremendous confidence in the fact that you're not going to have to look at a study where you don't have confidence, or you have to look again and again and again, or over and over and over again, as part of your search pattern, to make sure there isn't a pneumothorax or a pneumonia or a nodule or something like that. If you have extreme confidence that those things are not something that you have to spend extra time looking for, that you can look and know that it's not available, then you can be more efficient with the way that you're reading the studies. Contrary to that is that if that something gets flagged, you're going to know that you have to spend some extra attention on that examination. So you can like spread those exams out into different buckets and give them to different radiologists. And if you know what your task is kind of for that day, you're going to be able to kind of mentally be more efficient. Every time that we sign off an examination, it's always in the back of our heads that this is kind of like a legal document that we're putting out into the world, that we're trying to add value, and so we want to have that confidence, and anytime you have that confidence, that's always going to make you more efficient and ultimately make you a better physician.
Yeah, thank you so much. So I think if we look at really like what are the what the main advantage, but also the focus, not for us in the deployment rad, that is really like again, of course, try to support with the high volume and the pressure that of course is in the radiologist group, that, and focus on again, every exam need attention, but again, here is even like some exam they maybe require even more attention, let's say like that, and support the clinical decision making process. So and really like of course help the patient, but in the time as today where radiology shortage and everyone is working much higher with less. I think this is key to make also the care team work in a sustainable way, and so that's really like helping both side patient but also the care team itself. So with that, Khan, I don't know if you have a comment about this. Also, if you want to expand a little bit about what is going on today, in addition, of course, to the X-ray model and what we see now coming like in the short future and RSNA.
Yeah, absolutely. So, we released our chest X-ray model earlier in July of this year, which you guys started to work on. And then yesterday we announced our mammography foundation model release that you guys got access to, and really excited to see what you guys are going to do with those things, and folks can do this. And then we're going to be releasing more at RSNA and immediately after that. So would love for folks to come and see us at RSNA. We're going to be announcing a lot of amazing things at that time to do this. I think that was I know that we have tons of questions that we need to go through too. So maybe I'll jump into that and have Jordan talk about. Jordan, one of the question is, how many data sets did we need for fine tuning, and and how you thought about that, and what kind of things you use. I mean, we've seen as little as 100, 200 cases of fine tuning for certain use cases, but why don't you talk about what your experience was and how you guys, what kind of data set size you use for fine tuning?
Yeah. So I agree that it will be highly task dependent. So you may have some inklings or hunches beforehand what works. I know that for the specific applications that we have been working on, just by chance, we had quite a big set. So we actually had over 10,000. I don't think it would have been required. We had them to hand, so that's what we used. But I think you should expect, depending on task, to get going indeed from a couple of hundred into the low thousands, and actually expect things to work. But again, it will be task dependent, so your mileage may vary. Time-wise, I think, I don't know if we hit the week count, but we were pretty close, I think, on the turnaround time on that fine-tuning run. Again, it will depend on how much data you put in, and perhaps on how hard the task is in terms of it converging. But very tractable, again, in timelines much accelerated from the 1-2 year timeline that we've been used to from historic. So yeah, a little bit squishy answers, if you will, but the answers tend to be a bit squishy. So it will depend on your specific problem, but very transformative compared to what we have been doing traditionally.
And your longest run was under a week, correct?
It was, yeah.
Yeah. So it's like 2 years down to 1 week is kind of the efficiency we're talking about.
Yeah.
Nico, the other question people are asking, maybe I should answer that one about the regulatory side thing.
Exactly.
So because HOPPR is in pure API service, there's no user interface. So we consider ourselves a component of a software as a medical device. And if somebody is submitting their application for FDA clearance, then we would be the component. So component concept is very common in a hardware scenario where medical device manufacturers would outsource some components built under quality management system that can be incorporated into their device. It's a different concept, newer concept in software aspect of it. So we build everything under FDA's quality management system, under ISO 13485, and provide all those documentation for anybody who's trying to submit their application for FDA clearance. I think a lot of the stuff that is happening also is getting done under practice of medicine, where physicians, clinicians can make a decision on what they want to do for clinical practice and really tune the models per their liking, right? Because base model is not directly used as is. It needs to be fine-tuned per the physician specifications. What's the sensitivity, specificity, false positive value, AUC you want, and then that's under control of that clinical team and how they want to do it and deploy it in the local practice. But of course, if you want to go commercialize that model or that application that you build, you'll have to go through the regulatory process. So that's kind of how folks are thinking and using HOPPR as a component of a software as a medical device. Cool.
And I think if I can add to that on our, let's say, RadNet experience as well, I think when we look at this model, they are really, I think, effective. Has also the clinical use case is really well defined, and because in the past, it takes so long, to develop and fine tune this model. we tend sometimes to have one model that we want to take care of different clinical use cases, correct? So this capability now to go faster is really allowed us in the clinical practice to really focus on multiple different use cases at this point and make it much more effective. No, so like when you look at stuff like you see a lot of algorithms that they do really well in fracture as a single fracture, but they don't work in multiple fracture, correct? Because they're different model. Now with this approach, you can tune and tweak and see, okay, what is the clinical use cases and how do I answer to that? And that's really what we look, with RadNet and DeepHealth, when we want to develop and deploy in our model. So that makes everything much easier. Just to add to your comment.
And if I don't, you don't mind my comment on that, I think, the old model, you kind of structure the practice around the model, whereas now the model we can weave it into the practice, and you don't have to kind of rearrange your practice just to accommodate the model. You can get the model to accommodate the practice.
That's exactly right. It's a new playbook that we are trying to define here, and how you control what the model does in your clinical practice and your workflow versus changing your workflow to accommodate how a model needs to be used in a particular practice. Let's take the next question. So one question was, what tasks are available for this? So I think there are multiple tools we've made available for self-service fine-tuning through the API, and I would highly encourage you to look at the API documentation. Simple ones are building MLP classifiers for classifying different tasks. If anything more advanced is needed, our professional services team helps with that process to get that. And as I mentioned, chest radiography and mammography are the two models we've released so far, and more coming near future. There was a question asking. Yeah, go ahead, Nicola.
Yeah, I think the question asking for a little bit of RadNet. Probably that's what we were looking in the future. I think, as we said before, chest X-ray is our one main focus today, as Dr. Sine was explained, and as well as you saw HOPPR release also the breast model, and again, of course, breast is another field where at RadNet we are of course working, and it's part of priority as we do more or less 2 million mammogram as well. So everything that really we can expand in the field. And again, so these are probably the two short time field where we're gonna collaborate.
Very cool. So I think we've answered.
Yeah, I think maybe if you want to, again, I think a lot of people they're asking, where you can find material, where how do you start, how you really say it seems so simple. How do we start? Maybe you want to give a little bit of indirect indication?
Yeah, you can. HOPPR's portal platform is available. Documentation are completely available. Let me share my screen so we can actually see where it is. So you can go to platform.hoppr.ai/docs, and you'll be able to see the entire platform documentation. You can download the SDK for expediting the whole process. This Python library really makes it easy for development purposes, the fine-tuning process, how to do fine-tuning, the model library and all the models that are available, developer guide on how to do this. Really, we provide sample code that can be used very easily into your own application. SDK just makes the process really easy, and we'll be expanding these SDKs with more and more ways to fine-tune different aspects of the model. You don't do anything, right? Just seed without doing any hyperparameter tuning. And if you need more advanced hyperparameter tuning, some is available through our fine-tuning process, service fine-tuning. If anything more custom is needed, our professional services team and ML team can more than happy to help through that process. So I would encourage folks to have a look at the documentation and throw us any questions to help you guys get started.
Great. I think before I leave to you, Khan, to close, I just want to at least give, and again, if someone else also want to comment, I think For us, is really at DeepHealth and again RadNet. I think we are really excited about the partnership and more about the fact that it's really now fast to develop use cases, and it's kind of like becoming more and more interesting in see okay what we should tackle next. So we're less worried about probably the burden on the team developing and more focused on what we should do next. And also, I think that's really exciting. It remove really the side of looking more resource wise and focus on what we need to address. So from my side, is really exciting and really looking forward to the next step.
I think one of the things that we wanted to make sure is that the models are so flexible, can be used as any part of it, right? So if you want to use model to help from a workflow triage point of view, you want to have model help from the billing side of things, you have to model from the quality assurance part of things, or you want to be able to, as you guys said, right, identify findings and pre-populate them in the template for radiologists so that they're not missing those aspects of it. That can be done too, or even building it the way you guys have done an unremarkable model and pre-drafting template or selecting a template already for that particular aspect of it. It just really expedites the whole process. I mean, as Jason and I talk about, right, it's not the detection of the thing that slows us down. It's taking that finding and then putting in a text that other humans can understand is where the time is, and anything we can do to expedite that process. And that is such a custom thing. It's so different from rad to rad that trying to build a one-point solution that works for everybody else will be really, really hard to do. And that's why this kind of flexibility gives the power to the end user and how they want to deploy this.
And I think it's super important to kind of recognize that, in the real world, once you have and once you know that something like this is available, you start to think about how to solve your clinical problems differently. And that's kind of a tremendous breath of fresh air as far as like if I know that I had this process or whatnot to be able to put into play clinically in a very timely fashion, then I know that I don't have to wait 2 years and in order to be able to fix something, right? Like things can get fixed in a much more timely fashion and allows way more flexibility in terms of how the clinical practice functions on a daily basis.
That's absolutely correct. I think we maybe last question, Nico, and then we end. The question is, what were the greatest excitements and challenges we ran into? I think the biggest challenge really was the building the foundation models and all the tooling to be able to do this. Without a very large model that has seen everything, it's really, really hard to build fine-tuning tools to make it easy so that it takes Jared less than a week to fine-tune a model from scratch. So I think that was the biggest challenges. Took us a while to get there. I think we are definitely looking at other modalities right now and looking for clinical input, like what should we be focusing on, how important is CT versus MR, musculoskeletal. I know the RadNet team wants us to focus on musculoskeletal next. I keep getting reminded about that. So we are really taking that input to see how we can help this. And then the last question really is, I don't know if you want to take
FDA.
this.
Yeah, it just is not yet approved. Again, we are on really like testing phase, but again, the idea is of course like as soon as we make sure we have the right use case and clinical use cases, of course, like it will be up to us to bring it and to make it a product.
Yeah. Awesome.
Okay, so I think just thank you for the opportunity, at least for me, to be moderating the session. Can it was a pleasure, and of course, thank you to Jorit and Dr. Silvan to be here with us. So yeah, looking forward for the next step. So and I'll let you close.
Yeah, absolutely. I think you will see more coming from us. A lot of exciting stuff coming at RSNA. If you want to work with us, send us through a message through our website, and more than happy to have team talk to you and see how we can help. Thank you very much. Thanks, Jason. Thanks, Nicola. Thanks, Jared.
Thank you, Kyle.
Thank you so much.
Thank you, Nicola.
Thank you.
Thank you.